We continue with our block mesh file. In our example, we don't have any edges. In the next examples, we'll check what an edge is and how we can apply it. Now we reach the point where we must define our boundaries and boundary faces and introduce them to the software. The first boundary I want to define is my velocity inlet boundary. The boundary on the left side of the shape, I'll name it inlet. Its type is no longer wall. As you remember, we said that if our boundary is for the velocity field or the pressure field, in OpenFOAM we should use the term patch. With patch, I tell the software that this boundary either gets a velocity value or a pressure value, so it's not a wall anymore. The faces that form this boundary are faces that we can identify using the lower figure from the 3D view. The face we have is between points 0 and 4 and their corresponding 3D points, meaning points 0, 16, 20, and 4. Now, what should the order of these points be? The order must be such that if I place my right hand on the face and follow the points, my right hand thumb should point out of the computational domain. In this example, the point order is 0, 16, 24. This is the first face I have down here, but my boundary is made of two more faces that are inside blocks B3 and B4. So I press Enter and create parentheses. Now if I go Home and Tab. Now you can copy this again. Enter, Home, Paste. Okay, now I reach my second face. My second face is made of points 4 and 8, and their corresponding points, 4, 20, 24, 8. For the point order, use the right-hand thumb rule. So it becomes 4, 20, 24, and 8. Next I'll do faster. 8, 24, 28, 12, which corresponds to the face at the inlet of block B5. Now we've defined our inlet boundary. Now I'll define my next boundary. My next boundary is the one at the outlet. I want to define the outlet. I'll name it outlet, for example. Again, its type is patch. As you can see, my outlet is on the right side, and it is formed by three faces. These faces are inside blocks B4 and B7. For my right-hand thumb to point out of the face, I must go from point 3 to 7, then from 7 to its corresponding point, then come down, then return to point 3. So I write 3, 7. Then I'll write the corresponding points later. My second face is the one where I must go from 7 to 11. So in face 2 I write 7 to 11. Next is 11 to 15. Now suppose I want to write the corresponding points for the points I wrote here. First, I write the corresponding point of 7, meaning 7 plus 16 equals 23. Then 3 plus 16 equals 19. In the same way, with this same mindset, you can place the corresponding points for the points you wrote. Now I should have written the faces that form my outlet and the outlet patch here. In the next step, I want to write the faces for my square patch, this square. You can copy one of these boundaries. For example, I copy the outlet. First, I correct the name. I name it square. Then its type is no longer patch, it's wall. We want a wall. Delete the extra point indices. Now we apply this. Since I have 4 faces, I need one more set of parentheses. Let's look at the example. To make my right-hand thumb point out of the face, for example, the face shared with block B6, I must go from point 5 to point 9. So first, I write 5 to 9. I have the top face too. To apply the right-hand rule again, I must go from 10 to 9. So for my second face, I write 10 to 9. My next face is 10 to 6. Again, for the right-hand rule, the order should be 6 to 10, so I move from 6 to 10. Then my next face is 5, 6. To keep my right-hand thumb out of the computational domain, I must move from 5 to 6, so I write 5, 6. This might be a bit confusing. How do you decide the right-hand direction for this face? What you should keep in mind is that inside these blocks, V1, V0, etc., we want cells, so we have a computational domain. When defining the face shared between 5 and 6, my right hand must be oriented so my thumb points out of the face. It must not point inside. For example, if I write 5 to 6 here, when I move from 5 to 6, my thumb points upward and out of the domain of each of these blocks. So the way it's written here is correct. Now come and write the corresponding points. First, write the corresponding point of your second point, meaning 9. Then, 9 plus 16 is equal to 25, and 5 plus 16 is equal to 21, and in the same way place the rest of your corresponding points. Now I should have been able to form the faces that create my square wall. There should be 4 faces. Let's continue. Next, I have a boundary called the boundary wall at the top and a wall boundary at the bottom. Now you can either apply a wall boundary here, or you can apply a symmetry boundary. In this example, I'll use a symmetry boundary. So I copy my square boundary and name it, for example, wall up, top wall. I set its type to symmetry. To apply symmetry, you can write symmetryPlane here. This tells OpenFOAM that the face is a symmetry plane. Now I need to define its faces, the faces that are located at the top. Okay, before writing the points, I can copy this same boundary and create the bottom boundary too. That is, instead of wall up, I write wall down, and again I set the boundary to symmetryPlane. Now I write its face point indices. If you pay attention, we can again use this lower figure. To write the top wall face, to make your thumb point out of the computational domain, you should go from point 13 to 12, then 28, then 29. So the first face becomes 13, 12, 28, 29. The second face is 14, 13 plus the corresponding points. The next face is between points 15 and 14, so it becomes 15, 14. Here I have 3 faces, so I delete 1 extra. For the bottom it's the same. I also have 3 there. Now write the corresponding points. Write the corresponding points, 29, 30, and for the bottom it becomes 30, 31. Okay, now we go to the bottom symmetry boundary. That is the boundary at the bottom of block B0. To make the right-hand thumb point out of the face, I should go from point 0 to point 1, then 17 and 16. If you follow this loop, your thumb points out of the face. So I write 0, 1, and then I write the corresponding points 17 and 16. Next, the next face is the bottom face of block B1. Again, I go from point 1 to point 2, then to the corresponding points. So I write 1, 2, 18, 17. The next face is the bottom face of block B2, 2, 3, 19, 18. In this way, I was able to write the faces that form my wall-down boundary for you. Let's continue. Next, we need to write the faces for the front and back boundary, which is our empty boundary. For the front and back boundary, the faces that form this patch are written here. The first, top, set of faces includes points 0 to 15 and lies on the z equals 0 plane. The second set of faces lies on the extruded plane and actually forms the front. As a good exercise, you can try, without looking at the answer shown here, to write the point indices that form these faces yourself and place them inside the blockmesh file. In this way, once our boundaries are complete, our blockmesh file is ready to use. In the next part, we'll try to generate this geometry by running the blockmesh command.